A unit cell is a fundamental building block of a crystal. Here you can see a unit cell. At the corners of the unit cell there are lattice points. The lattice points can also appear on the faces of a crystal or at the center of the crystal. When a unit cell is arranged in 3 dimensions, we will get the complete crystal structure called the space lattice or the crystal lattice. The space lattice is an array of points showing how the constituent particles are arranged at different sites in 3-dimensional space. An important thing to remember is that the lattice points are purely mathematical concept, but atoms, as you know, are physical objects. The absolute positions of the points of a lattice and hence the unit cell are arbitrary with respect to the pattern. The lines joining the unit cell are drawn simply to represent the 3 axes by which the relative positions of the points can be described. Also, the lattice points do not always lie at the center of atoms or coincide with the unit cell vertices. Say, in this figure, the first picture gives the 3-dimensional periodic arrangement of atoms in the crystal. The second picture shows the corresponding space in the lattice. In this case, the atoms lie at the same point as the space lattice. Another important feature of the unit cell is that it cannot have all shapes. A unit cell has such a geometry that when it repeats in space, it will fill the whole space. Means there shouldn't be any empty space or voids left after arranging it in space. Thus, a unit cell can have a cubic structure since it can be arranged without any voids. A spherical or pentagonal shape is not possible for a unit cell since its repetition in space does not fill the space completely and leaves voids. A unit cell is characterized by 6 parameters. These are called the unit cell parameters. These are the distances of the points along the axis A, B and C, and also the angles between the axes alpha, beta and gamma. Let's take this vertex of the unit cell as the origin of the 3 axes. The distance of this lattice point from the origin along the x-axis is the unit cell parameter A. The distance of this lattice point from the origin along the y-axis is the parameter B. Similarly, the distance along the z-axis is marked as C. Now let's look at the angles. The angle between B and C is marked as alpha. The angle between A and B is gamma and the angle between A and C is beta. To describe a unit cell, we should know the unit cell parameters. The distances A, B and C gives the lengths of edges of the unit cell. The angles alpha, beta and gamma gives the angles between the 3 imaginary axes.